Hello guys, this video is for Algebra 2, Week 9, Tuesday and Thursday on the topic of properties of logarithms. We are going to start off with a couple of things that you have to know before we move on. If you guys, if you remember, when we have log of a certain number, this has the base of 10, right? It's invisible, but it's really 10. And there's something that I have never introduced to you is called ln. Okay, ln, it's very, very similar to log, except actually we call this the natural log. And this one, the base is actually e when it comes to log. Okay, so ln is the same thing as saying log base e. But here's the thing, don't get scared when you see ln or log. The log and ln share the same properties that we're going to go into in a little bit. Properties below. And I'm going to highlight this so you know it's pretty much the same. Okay, and there are 4 rules that I'm going to be going over, and then I'll show you some examples. So let's start off with the first rule called zero property. Okay, there's the review column, which is exponents. It's something that you kind of already know. And then there's a focus column, which is going to be useful for your homework later. And that's mainly the column that I want you to focus on. Okay, so zero property in exponents is if I have anything that raised to the 0 power, this is the same thing as saying 1. Okay, in the log form, if I have log base b of 1, this is going to equal to 0. Because think about it, if I convert from this one over to the log form, from exponent to log, this is really how it looks like. Okay, so keep in mind, anything, no matter what your base is, if you have a 1 there, it equals to 0. Okay, and then and then the next form I want you guys to look at is product rule. Okay, product rule in exponents is x to the a times x to the b, and this really equals to x to the, what do we do with exponents? We add it up. Okay, but in the log form, let's say if I have log of xy, like this. This is the same thing as saying log x plus log y. Let me rewrite the whole thing. So log of xy, it equals to log x plus log y. Okay, and then the next one is called quotient rule. Quotient rule, that means division. If I have x to the a power over x to the b, this equals to x to the a minus b. Okay, so logarithm, if I have a log of x over y, this equals to log x minus log y. Okay, we'll practice these rules in a little bit. The next one is called power to power rule. If I have x to the a to the b power, if the exponents are next to each other, we usually multiply it together. Okay, and now If I have log base b of x to the nth power, like this, okay? Anytime you have raised to an exponent, we take that exponent and we drop it in the front, which is going to look like n times log base b of x. This is how it looks like. All right, let's use these rules and show some examples. I'm going to do log of x to the fifth power, log 6x, ln 3y to the second power. Okay, so let's use the rules above and see if we can break it down using the rules. So the first one right there, I'm going to be using the power to power rule. Take the 5 down to the side, which will look 5 times log of x. That's it. Okay, next one. If I have log 6x, I'm going to be using the product rule because these two things are being multiplied right there. And then I need to break it down into two logs, which is log 6 plus log x. That's your answer. Last one, expand it as much as you can. But first off, I see two things that are being multiplied. I see a 3 and a y squared that's being multiplied. So let's rewrite it as this is ln. ln 3 plus ln y squared. And keep in mind, if our rules are using log, ln is serving the same rules. So ln 3, I can't do anything about it anymore, so I'm going to rewrite as ln 3 plus, you see an exponent? I can bring it down to the front of the ln on the second term. So a 2 ln y. That will be your answer. Okay? Let's do some more difficult ones. Let's do log 7, base 7 of 3y to the fourth power, x to the third power. This is a more complicated one. And let's also do log 5 of 3xy. Okay. Oops. First one. What's being blocked with all of this whole entire term? I believe it's a division sign that I can actually break it down into two parts first. Okay, so we have log base 7 of 3y to the fourth power minus log base 7 of x to the third power. Okay, if I have to continue from here, the first part right here, I can actually break that down into two logs again, which gives you log base 7 of 3 plus log base 7 of y to the fourth power minus, can I do anything to the last part? I can bring down the 3 to the front of the log, which is 3 log base 7 of x. Am I done? No, I still have an exponent, so I'm going to keep going. Log 7, 3 plus 4 log base 7y minus 3 log base 7x. That's your final answer when you expand everything. Okay, last one, log base 5 of 3xy. I'm going to break it down to how many blocks do you think I can break it down to? I have 3 times x times y. So there's actually 1, 2, 3. Log base 5 of 3 plus log base 5 of x plus log base 5 of y. And that's your answer. Okay, I'm going to show you your homework on Tuesday is page 3. So you have 10 questions. I'm going to leave the top ones for you to do. Number 6, keep in mind, this is log p to the q power. Okay, I guess that we can do that one, finish that one. So if I have anything to the certain power, I take that exponent, bring it to the front, which is q log p. Okay, let's do number 9. Number 9, I have how many things are being multiplied together? Got the 7 times the x squared, right? So I'm going to rewrite it as log 3 of 7 plus log 3 of x squared. Can I do anything for the first part anymore? No, I just rewrite it. How about the second part? I can take the 2, bring it to the front, which is 2 log 3 of x. That's your final answer. Okay, so go ahead and finish the rest of day 2. I'm going to go back and go into day 4. So if you look at day 4, you're going to be rewriting each of the log expressions. It's all super expanded. We're going to be rewriting it as single log. So we're going to put everything back together. It's like the reverse. Okay, so I'm going to show you a few examples. This is for Thursday. And rewrite as a single log. And here are some of the questions. Let's do one more. Okay, for the first one, what can I do to start off? I see a plus sign with the same base. That means later I'm going to be multiplying something together. But before that, do you see this 3 is in the way? Okay, this 3 needs to go back up to the exponents, which we rewrite it as log base 2 of 10 plus log base 2 of x to the third power. Okay, now that there's nothing in front of the log, I can go ahead and put that together as one log. So log base 2, 10 times x to the third power. And that's your final answer to that question. Okay, try the second one. In front of each of the log, do you see a number? Yes, I can take that number, raise it to the exponent, take that number, raise it to the exponent. So we get log 12 to the fourth power minus log 2 to the fourth power. Okay, and then we keep writing. We're going to put it together as one log. And since this is a minus sign, we're going to be dealing with division sign. Because minus, if they're expanded, put it together, it will be division. 12 to the fourth power over 2 to the fourth power. Okay, you can leave it like that unless you want to use a calculator and continue solving for this. Okay, last one. I have a more expanded one. Okay, so let's start off by putting the 3 into each of these. So I have 3 ln 3 minus 3 ln x plus ln x minus ln 9. Okay, so right here, I notice that the ln x, like this part and this part, I actually can combine that together. And that will turn into negative 2 ln x. Okay. Anything else can I do with this? I can take the number from the outside, bring it up at the exponents, bring this up to the exponents. The last one doesn't have anything. So it'll be ln 3 to the third power minus ln x to the second power minus ln 9. Okay, so the negative sign, remember that represents division. So it'll be ln 3 to the third power is 27. So I'm going to put 27 over x squared minus ln 9. Okay, so we still need to put it together as one log. This would be ln 27 over x squared. If I put over ln 9, if I put over 9, that's the same thing as saying multiplying 9 at the bottom. Okay, so the 27 and the 9, they actually can get canceled out with the 3 at the top. So your final answer, it will be ln 3 over x squared. Okay, this is a more challenging question, and that's how it looks like. Okie dokie, let me go into your homework, day 4, and let's do a couple of these. I don't think these are as difficult, hopefully not. Let's do number 7 and number 2. Okay, number 2, in front of each of the log, actually all 3 of them have a base 4. Okay, so that means we can combine them all together. But before that, I see a number 3 in front of this. I have to put it back into the exponent, which is log base 4 x to the third power plus log 4 of y minus log 4 of z. Okay, let's keep going. Start from left to right. I can put it together, put the plus sign of those logs together by putting log base 4 of x to the third power times y minus log base 4 of z. What does this give you? It's going to be log base 4 of the minus sign serves as a division sign. I'm going to put z at the bottom, and the x to the third power y goes to the front. And that's my final answer. Now it's in one log. Okay. Number 7. It's using ln, and in front of each of the ln, I see a number, which I'm going to put at the exponents. See the number, put it as the exponents. So we write it as ln 2x plus 3 to the second power. The second power goes outside. Minus ln y minus 2 and to the fourth power. Okay, and you see this division minus sign? Again, it serves as a division sign. So I have ln and a division sign ready. And all you gotta do is just put whatever was in the beginning to the second power, y minus 2 to the fourth power, just together like this. That's your final answer. Okay, so that's all I'm gonna show in this video. If you have any questions, feel free to ask me. And that's it. Have a good day. Bye.